Hi friends, welcome to Orbit. Today I am going to discuss one of the main concepts in electrodynamics, that is Poynting Theorem. This Poynting Theorem is crucial for understanding how energy is transferred by electromagnetic waves. So, first, the work necessary to assemble a static charge distribution or the work required to assemble an electric field is given as WE is equal to epsilon 0 by 2 integral E square d tau, where d tau represents the volume. So volume element d tau. E is the resulting electric field. Now the magnetic field, the energy stored in the magnetic field given by Wm is equal to 1 by 2 mu 0 integral B square d tau, where B is the resulting magnetic field. So the total energy stored in electromagnetic fields can be written as the sum of the two. So UEM, that is energy stored in electromagnetic field, is equal to, we can add both this WE and WM. So we get half is common in both, half integral epsilon 0 E square plus 1 by mu 0 B square d tau. So we know that from Lorentz force law, the work done, or F dot dl, where F is the force and dl is the displacement elements. So F dot dl is equal to Q into E plus V cross B dot V dt. So we know that V cross B dot V is 0. So we get Q E dot V dt. So now we can substitute rho d tau for Q, where rho is the volume density. So we can write here F dot dl is equal to, instead of Q, we write rho d tau and then E dot V dt. So here rho V is equal to J, current density. So E dot J d tau dt. So we can write the rate at which the work is done on all the charges. This is about a single charge. So here the work done on all the charges in a volume V. So when talking about all the charges in a volume, we take integral over V. So integral over V, what we got here? E dot J d tau. This dt has been gone to the left side. So using Ampere-Maxwell law. Why? Because we want to replace this E dot J in the right side of the equation. So E dot J is equal to 1 by mu 0 E dot del cross B minus epsilon 0 E dot dou E by dou T. So we know that. So we want to replace this E dot del cross B. So we have one relation. Del dot E cross B is equal to B dot del cross E minus E dot del cross B. Let it be the del. Faraday's law, we know that del cross E is equal to minus dou B by dou T. So here, instead of this del cross E, we can substitute minus dou B by dou T. And taking this term to the right, we get E dot del cross B is equal to, substituting minus dou B by dou T instead of this. So minus B dou B by dou T, and this term to the right side, del dot E cross B. So also B dot dou B by dou T is equal to half dou by dou T B square, and same relation for electric field also. So we can substitute these two, substitute this equation here, then we get an equation for E dot del cross B, substitute that in the above equation. So here equation 6, E dot J is equal to 1 by mu 0. Then E dot del cross B. What we got for E dot del cross B? Half dou by dou T B square minus del dot E cross B. Substitute that here. Then what's remaining? Epsilon 0 E dot dou E by dou T. E dot dou E by dou T, substitute this equation. So we get an equation like this. Then we open the brackets here. So first term gets 1 by mu 0 here, and here also 1 by mu 0 comes. Then we group together the terms with electric and magnetic fields partial derivative, dou by dou T B square and dou by dou T square. Group that terms together. So what comes common? Dou by dou T is common in both terms. Half is minus half is common in both terms. So take it outside the brackets and remaining here. So minus this. So this is an expression for E dot J. According to equation 5, dw by dt is equal to integral E dot j d dot. So we, in this equation, here instead of E dot j, we can substitute this equation. So now we get dw by dt is equal to minus d by dt integral v half epsilon 0 e square plus 1 by mu 0 b square d tau minus 1 by mu 0 surface integral e cross b dot dx. So previously we had volume integral del dot e cross b dv. So we can convert that into surface integral using this equation, cross integral over s e cross b dx. When the volume integral is converted to surface integral, this del can be removed and this dot comes to here. So substitute that. So what we got now, this equation is known as the Poynting theorem. It is also known as the work energy theorem of electrodynamics. The Poynting theorem states that the work done on the charges by the electromagnetic force is equal to the decrease in energy stored in the field plus the energy that flowed out through the surface. We can get this statement with this equation. So the work done on the charges by the electromagnetic force, that is dw by dt, is equal to the decrease in energy stored in the field. We know that this is the energy stored in the field. So why said about decrease? Here there's a negative sign. So decrease in the energy stored in the field minus, so we wrote less the energy that flowed out to the surface. This is the energy that flowed out to the surface. So this is the difference between the negative of the energy stored in the field and that flowed through the surface. That is Poynting's theorem. So we also have another concept, Poynting vector, indicated by the letter S. Vector S is equal to 1 by mu 0 E cross B. This Poynting vector actually gives the direction of travel of an electromagnetic wave. This is a fundamental concept in electromagnetism that links the electric and magnetic fields to the flow of energy, providing insight into the direction and intensity of electromagnetic waves. Thank you.